ZAS Robotics, Navigational Robot Car-1, master real-world navigation using sensors and motion algorithms. Robots don't become intelligent by learning in isolation. First, they learn to sense the world. Then, they learn to move with precision. Then, they learn to communicate. But true robotics begins when all three come together, in the real world. Introducing the ZAS Navigational Robot Car-1, the first step into real autonomous robotics. Until now, students have worked with individual components, sensors, motors, and communication systems. But real robots must make decisions, react to environments, and navigate unpredictability. Car-1 is where theory becomes behavior. The Navigational Robot Car-1 is a fully assembled, ready-to-run robotic platform designed to eliminate wiring complexity and focus purely on algorithms, behavior, and intelligence. The Car-1 system comes complete with a professionally engineered robotics platform. The kit includes fully assembled navigational robot car, UK-engineered motor controller board, pre-mounted DC motors, ultrasonic sensor for distance detection, IR sensor array for line tracking and obstacle sensing, OLED display for real-time system feedback, clean, well-organized chassis with integrated power system, pre-installed wiring, no messy cables, everything required to start building real navigation intelligence, instantly. The chassis is carefully designed for durability, stability, and clean internal routing. Power delivery, sensor placement, and motor control are all optimized, allowing students to focus on how robots think and behave, not wiring issues. This is not a toy. This is a real robotics development platform. Car-1, demonstrations, obstacle avoidance. Using ultrasonic sensing, the robot detects obstacles in real time and makes intelligent decisions to avoid collisions. Line following. With IR sensor arrays, the robot learns to follow paths with precision, a foundational algorithm used in industrial automation systems. Wall following. The robot continuously adjusts its motion to maintain distance from walls, demonstrating real-time feedback control. Edge detection and safety. Edge detection prevents the robot from falling or leaving boundaries, a critical safety behavior in autonomous systems. Real-time feedback and debugging visual. With real-time feedback on the OLED display, students can debug, analyze, and refine robot behavior, just like professional robotics engineers. Learning outcomes. Students working with Car-1 develop real-world navigation algorithms, sensor-based decision-making, integration of ultrasonic and IR sensing, motor control for autonomous movement, reactive robotics behaviors, algorithm testing in controlled environments, debugging using real-time system feedback, understanding of how sensors and motion interact in physical systems. This is where robotics becomes intelligent behavior, not just code. Navigation modes and algorithms. Students master 14 navigation modes, including obstacle avoidance, line following, wall following, internal, external, and left-right walls, edge detection, tabletop, pit avoidance, speed control, PWM, precision turning, sensor-driven decision logic. Each mode builds deeper understanding of how robots interact with the environment. Preparing for advanced autonomous robotics. Car-1 builds the foundation for autonomous navigation systems, SLAM and mapping, deep and reinforcement learning in robotics, AI-based decision-making, real-world robot deployment. It bridges the gap between learning components and building intelligent machines. The ZAS Navigational Robot Car-1 transforms robotics learning from theory into real-world behavior. With a fully assembled platform, integrated sensors, and structured navigation algorithms, students can focus on what truly matters: building intelligent robotic systems. The UK-engineered design ensures stability, clarity, and rapid experimentation, enabling learners to develop real engineering skills. Because true robotics begins when machines don't just sense or move, they navigate the world intelligently. Visit our website, explore our GitHub, watch tutorials on YouTube, and take your next step into advanced autonomous robotics, starting today. In this advanced robotics journey, you are not alone. You have the support of the strong ZAS Robotics community. Follow us.